So here we're going to take all the information from Bivariate data and we're going to pull it all together into one question. And that's why it says, let's bring it all together. So you may want to pause the video and make sure that you have all this copied down into your notebooks before you move on, okay, with me, okay? After we begin the table, we're going to be given like parts A through G. So part A, the question says, create a scatter plot. So we want to draw a scatter plot for this information here. Remember when we were talking about our table, we were saying that the first line in the table is our X, the second line in our table is the Y. So if I was creating a scatter plot, and I'm just going to do a small one kind of over here to the side. If I was doing a scatter plot over here, my X value is going to be my fat, and then over here on the side would be my calories, my Y value. You need to make sure that when you're making a scatter plot, you have the sides labeled. That's a big piece of this, and I'll be making sure that you have those to get full credit. Now, our fat goes from 19 to 43, so I'll just use increments of 10, 20, 30, 40. And we can extend that a little bit and go to 50. Now my calories start at 410 and go all the way up to 680. So I'm going to put a break in my graph like I did in my notes, and I'm going to start here at 400 and then go 500, 600, 700. So I can have all those data points. And now all you want to do is just plot where you think those points should be. So 19 and 410. So 19 and 410 would be about here. Then we have 31 and 580 right here. 34 and 590. 35 and 570. 640, or I'm sorry, 39 and 640. And then 680, 39 and 680. And then 43 and 660. Again, it does not have to be perfect as long as it's in the general area where the points are. I'm not going to be too picky about. As long as your sides are labeled, you'll be okay. So we created our scatter plot. Now we're going to write the linear regression. Equation. So to write our linear regression equation, we need to get our calculator. Remember, the first one goes in for L1, the second one goes into L2. So we hit Stat, Edit, and remember, if you have information in your calculator, you can either reset your calculator or clear it out. Never hit delete. And we're going to enter in this information. 31, 34. Okay, so we have our information in here. Stat, Calc, and we're going to select option 4 for the linear regression. Enter, 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 enter. And we have this here. Okay. So here, our equation would be y equals, we plug it in, 11 point, if it doesn't give us a decimal place at once, just round 2 decimal places. So we'll say 11.06x plus 210.95. The next thing it's going to ask for is the correlation coefficient. And then once it asks you for that, it's also going to ask you to describe what that correlation coefficient is. Now you can see when I have brought up my linear regression equation, I didn't get a correlation coefficient, and that's because my stat diagnostics is not on. So to turn it on, remember, you go to Mode and go all the way down until you see Stat Diagnostics, move over to On, and click it so that it's on. Second mode will bring you back to your main screen. Stat Calc, I'm going to do my linear regression again, and this time my R value should show up at the bottom of the screen, and it does, and it says that R is equal to 0.96. So that is my R value, my correlation coefficient, and I want to describe what this is. So our correlation coefficient, remember, is going to be strong or weak depending on how close it is to 1. 0.96 is very close to 1, so I'm going to say it is very strong. And then we need to talk about the direction. This is a positive value, so positive correlation. The next question that you're going to see, it's going to ask, what does the y-intercept mean? So now our linear regression equation is a linear equation in that form y equals mx plus b that we've learned in the past. And then here m stands for the slope and b stands for the y-intercept. So we're talking about the b value here. The b value of this equation is that 210.95. Now, if you can't figure out and tell me what does it mean, at least write down what the y-intercept is so I can give you partial credit so that I know that you can identify what the y-intercept is. So what does the y-intercept mean? Well, the y-intercept is where it crosses the y-axis, and if it's crossing the y-axis, that means our x value is equal to 0. So if we had no grams of fat, that would be how many calories we'd have. Okay, so that's what I can write as my explanation. The amount of calories in a burger with no fat. Or you could write 0 grams of fat, however you want to say that. It's going to ask us for the y-intercept, and then it's going to ask us for the slope. So the next one says, what does the slope mean? So now our slope value we've already identified as what comes in front of x. So our slope here is 11.06. Remember when we learned slope in the beginning of the year, okay, or if you learned it in other classes, okay, depending on what class you're watching this in, we know slope is rise over run, the change in y over change in x. So our value of y is calories, so it's the calories for fat. Calories, we have 11.06, and if I wanted to turn this into a fraction, I would have to put it over 1. So to explain what the slope means, it's 11.06 calories for every 1 gram of fat. So in general, if we want to generalize this, it's the amount of calories for every 1 gram of fat. Once you identify the slope and the y-intercept, it's going to ask you to predict, okay, or to use that equation to find something else out. So this question says, how many calories would a burger with 28 grams of fat have? So here it wants us to find how many calories. We know the calories are y value, so that's what we're going to be looking for. It tells us how many grams of fat, Grams of fat is our X value. So we're going to take 28 and we're going to plug that into our equation from right here in for X. So Y equals 11.06 times 28 plus the 210.95. 11.06 times 28 plus 210.95. And we get 520. And we can round this to the whole number. Let's round that up. Let's just say 521 calories. And now we're going to go over what you're probably going to see. And I'm going to put a star next to this here because this one is going to be a little bit different and you may see it as an extra credit, okay, or a special type of problem. And I just want you to have it kind of starred in your notebook. A burger has 573 calories. How many grams of fat could it have? So this time they've given us how many calories are in the burger, and we need to figure out how many grams of fat there are. So this one's kind of backwards. They've given us the calories, so that's the Y. We need to find out what X is equal to. So we're going to use the same equation, only this time we're going to plug 573 in for Y, and we're going to have to solve the equation for X. We're going to solve this equation just like we've solved equations all year. If I'm trying to get X by itself, I'm going to cover this up and I'm going to subtract 210.95 on both sides. $573 minus 210.95 equals 362.05 equal to 11.06x. I want to get x by itself, so I'm going to divide by 11.06 on both sides. And then I get this number divided by 11.06 gives me, and again, we can round it, let's round it to the whole number, that's fine. And we